and Association of Energy Engineers is quite committed to deliver and increase the knowledge on energy efficiency. And today, when we are in era of decarbonization, sustainability, importance of energy efficiency has gone up. And as you all know, this Association of Energy Engineers is a US-based association of practicing engineers who are dedicated to energy efficiency. And Association of Energy Engineers Western chapter, Western India chapter, is basically a chapter like several other chapters across the world, who is completely committed to improve the knowledge and understanding of energy efficiency in the region, and deploy this latest understanding of different technologies in a simplest possible manner. I'll begin my presentation. Is my screen visible?
Yes.
Yeah. So hello everyone. Today we are going to talk very conceptually on the subject. Basically, everybody is talking about sustainability, and we have to achieve sustainability. And for this, the means are many, right? So we'll see the relationship of energy efficiency with sustainability today, right? So let's see. First of all, let us attempt to define sustainability, and let's see what it is, right? So here is a definition given by University of Michigan, which is considered to be the most accepted and oldest definition in the field. And it talks about people, profit, and planet, right? Well-being of people, profit, and planet, right? So on the left-hand side, if I read the definition, so quite simply, sustainability means meeting the needs of the present without compromising the ability of future generations to meet their own needs, right? Like it's very clear, we are consuming coal, we are consuming petroleum oils, right? And these are not replenishable sources. These are actually getting depleted, right? So considering this definition, we are not following this definition, and we are ourselves consuming these resources and not leaving it for the future generations, right? So the focus is fundamental on three things when we talk about sustainability, or when the world talks about sustainability. When the UN Charter talks about sustainability, it is people, profit, and planet, right? So people is with social well-being, profit is with economic well-being, and a planet talks about the environment health in the simplest possible manner, right? So qualitatively, one can speak a lot on sustainability. It is needed. It is definitely required to have the world to sustain, right? Without this, the world will not sustain, and so on and so on, right? But we need to know the ways and means to achieve sustainability. So that is the primary purpose of today's session. So moving next, let us see the numbers, right? So these are different numbers produced by different organizations world across, right? So if I see the left-hand block, because what happens is we understand numbers, right? So let us try to understand sustainability by numbers, right? So as we all know, Honeywell is one of the leading organization in HVAC segment, right? So 50% of its product talks about energy efficiency, right? And another is with 27. Then one is with 1 billion renewable energy production, right? So these are like these different numbers world across from different organization, right? From US EPA also, right? So with this all, we are trying to understand basically when we talk about sustainability, what is the way ahead, how to achieve this, and if at all any role energy plays and then energy efficiency plays, we are trying to understand this. On the right hand side, if we see, so then there has been a global survey wherein from different continent we see that in the year 2011 and 2014, right? So definitely now we are in 2023. So the portion of the green circle has certainly increased. What it means clearly is that willingness to pay price for sustainability has gone phenomenally up. We all ourselves see an impact of global warming, and this necessity right, has been felt by everybody, right? So with these fact numbers, let us proceed further. Now, what happens is, as I initially said in my presentation, that to talk about sustainability is a very good, but what should be the action points? How should be the action points? Then and only then we can engineer something, right, to achieve sustainability, right? So, as in the definition, it was said that people, profit, and planet, right? So, from the till the left hand side, it is all from the different organizations or different bodies, right, across the world, right? But the right hand interpretation is my interpretation, purely my interpretation as a professional in the field, right? So what happens is social well-being is directly connected with the per capita income of any individual, right? So if the per capita income is good, definitely social income, social well-being will be much better, right? But it is a fact that with higher per capita income, everybody's energy consumption is going to go up. It is a fact. All the developing countries have much lesser per capita energy consumption as compared to developed countries' per capita energy consumption, right? So the right hand side of the linkage is completely by me as an individual, right? And the profit when we talk about, right? So if we see the cost of consumable, that is other than the raw material, right? If we see the cost of production, so after the manpower cost, the second most important cost is energy cost. And when we talk about planet, right, still the energy generation from the fossil fuel is the phenomenal part, and the renewable part is quite a negligible part, despite the renewable percentage is going up very fast. But it is still today world over a very small percentage of the total energy. I mean, the electricity generated out of different sources of energy, right? So the third one talks about least GHG emission per unit of production or services consumption, right? So with this three fundamental logic, we see that whether we talk of people, whether we talk of profit, or whether we talk of planet, fundamentally the energy plays a very significant role, right? If you figure out any single parameter, right, which is going to impact people, profit, and planet, right? So energy plays a very important role. This we all agree, right? So let's proceed further, right? So on the left hand side, we talk about sustainability, we talk about decarbonization, we talk about climate change, we talk about global warming, and we talk about GHG emission, right? And these are, I mean, great subjects to talk about. However, what we need or what the world need is a specific actionable agenda, right? And a specific actionable agenda moves around numbers, right? So when we say numbers, so what these numbers can be, right? So these are specific energy consumption, which clearly means unit of energy consumed per unit of production, or GHG emission per unit of production, or the electricity consumption or fuel consumption per day, right? Or for a hospitality industry per room per year or per bed per year for hospitals, right? So these numbers speaks quite a lot, right? Or percentage share of renewable energy in total energy consumption, or utility energy consumption per unit of production, targeted percentage of energy consumption reduction this year, right? Total budget allotted for energy consumption or GHG emission reduction projects, and if at all any organization is doing anything for GHG offset, right? So when we talk about these numbers, we get some clarity of to-do agenda, right? But finally, where we have to reach, whether we talk of objective or we talk of actionable agenda, in order to reach sustainability, that to prevent the resources from getting obsolete or getting totally consumed, right? We need to be net zero. So net zero means what? Net zero in simple terms means, first of all, we consume for our all the requirement, right? I'm not saying the requirements needs to be reduced, but the requirement must be met in a most energy efficient manner, so that our energy requirement itself is reduced. And then whatever is our energy requirement, it should be generated from a renewable sources. So in the simplest possible definition, this is how net zero energy is defined, right? In our country, CII has taken a mandate with its GBC, that is Green Business Center, right, to designate the industries and the commercial buildings with net zero energy, which is a phenomenally great initiative, right? So I repeat again, what does net zero energy means? First of all, you reduce your energy consumption through energy efficient means, and then provide a renewable sources of energy for all 100% of your remaining energy requirement, right? So then what is happening is you are net zero. Same way it is net zero carbon, right? Net zero carbon actually includes other sources of carbon emissions also, but in this presentation or in this session, we will not touch net zero carbon. We limit it to a net zero energy. So with this, when we move further, right? So what are the options, right? In order to achieve, we saw the relationship of sustainability with energy, right? And now the energy sourcing is what we are talking about, and fulfilling our requirement with the limited energy that is available. That is what we are talking about. So the means to become net zero are basically renewable energy and energy efficiency, right? So in renewable energy, we know very well solar rooftop, right? Then we have dedicated windmills, right? And third party sourcing of renewable energy, right? These are different options to source the renewable energy, right? So what happens is solar rooftop has a limitation, dedicated windmills also has a limitation, and third party sourcing is also having limitations. And we will come to what energy efficiency can deliver a bit later. To understand the problem, right, or to understand what energy efficiency can do, or why energy efficiency is needed, or how sustainability and energy efficiency are related to each other, let us take a practical example, right? So there is a large corporate which is having a manufacturing and processing unit, and that wishes to achieve net zero energy, right? Net zero energy, again, I would repeat a definition of reducing the energy consumption first, and then getting the remaining energy completely from renewable sources. The renewable sources can be from its own rooftop, or from its own windmill, or from a third party, right? So what is the present situation? To simplify the understanding, I have made the numbers to per day consumption. So 12,500 units are required per day, right, for running the manufacturing machines and utilities. And 800 liters of diesel is required per day to run the boiler to meet its steam requirement. And now what happens is the corporate goes for a solar photovoltaic, which is 1000 kilowatt. And this 1000 kilowatt capacity is actually limited by the contract demand, which the company is having with the utility. Beyond that contract demand, one cannot go for a net metering option. There are various rules. These rules keep changing, but definitely this number of kilowatt is limited by the contract demand that you have with the utility. Now let us see what happens. Despite going for the maximum solar photovoltaic local generation, what is happening is finally from 1000 kilowatt, one can get 4000 units to 4500 units per day, because it is 4 to 4.5 kilowatt or watt per watt hour per watt of solar capacity installed in a day, right? So you cannot fulfill your 12,500 units of energy requirement per day despite going for a full capacity solar, which is possible, right? So here it is possible to reach to 36%. So these numbers are just for conceptual understanding, right? But that is what is happening. I mean, with the full capacity required, this reaching to 1/3 is also one of the highest achievement. Otherwise, most of the companies have been able to reach out to 5% or 10% or 15% of its energy requirement, right? Then what happens? Another thing with the grid based net metered solar generation is basically whenever there is no grid electricity available, and when you are generating electricity from your DG set. So in this particular case, 8 to 10% of electricity generation was not happening because grid electricity was not there, right? So that was a situation based loss, right? And boiler is converted to agricultural waste based briquette. So that's how the 100% of HSD consumption can be offset, right? So financially also it's a very viable project, right? The payback period of overall investment can be as less as 1.5 to 2 years, right? So this is phenomenal, right? But now how do we go about the 2/3 of the electricity requirement? What else can be done, right? From this kind of initiative, it looks like that the best which is possible that has been done, right? But friends, this is not a full stop. A lot can be done, Now let us evaluate the same plant situation from the energy efficiency perspective, right? So what happens is the moment we talk about energy efficiency, there are plenty of technologies. I think I would say very frankly and very confidently, as many as number of medicines available on a pharmacy shop, right? So obviously the first thing goes that how do we get 8 to 10% of loss of generation back, right? How do we improve DG loading and DG performance to get 3.5 units per liter of diesel, currently which is 2.75 units per liter of diesel, right? Then let us go to the specific plant details, right? Plant details would have several utilities, would have several manufacturing operations, right? So in this particular case, there is a vacuum pump particular technology that can be replaced by another technology. And then the vacuum pumps are basically 35% of total connected load. So which is a fair amount of load which needs to be addressed, right? Then today, the technology of I5 efficiency motors that is available, which is resulting into almost 10 to 30% savings as compared to existing I1 or I2 level of efficiency motors, right? Then one can go for direct drive instead of belt drive in this particular case. Right? Whatever I am speaking is about this particular case. The work is ongoing at this point of time, right? The utility can be automated, which can give 5 to 10% saving, right? And replacing compressed air totally from cleaning application and providing ring or turbo or lobe blowers, which would deliver 1 to 2 kg per centimeter square of pressure, right? Right now, if we are using compressed air, the pressure is 5 to 6 kg minimum, right? And with a high velocity nozzle, right? So friends, what you see that there are plenty of medicines available which a field of energy efficiency can offer for reduction in energy consumption. Let's move further, right? The compressors go load unload, but when they go unload, the total energy consumption is not brought to zero, right? They run no load, right? And because of corona and this kind of situation, many of the plants run quite underloaded, right? Which they have never seen that kind of a situation. So these kind of situations improve no load losses quite significantly. So that can be addressed, right? Then what happens is a lot of single phase load can still be sorted out with energy storage option, right? Herein we are not coming into the net metered energy requirement of utility, right? What is being done is that single phase electricity load is first converted to energy efficiency with energy efficient lighting through LED and BLDC fans. Most of the units have already done LED, right? But we hardly see BLDC fans applications, right? So this energy consumption requirement is brought down, and then it is completely generated by a isolated solar photovoltaic location, right? And that requirement is fulfilled through that, right? The day lighting and the natural roof ventilation instead of powered exhaust fan, that is where a lot of development has happened. So friends, my objective was not to discuss different energy efficient technologies in this particular session. What I wanted to say is that the number of options are really as many as number of medicines available in a medical shop, right? And the list goes on, right? So challenge is to figure out which are all those technologies which are useful, which are suitable in a particular case, right? So with the development of so many energy efficient technologies, right? Today, I can say with a lot of confidence that almost 20 to 40% of energy consumption, right, can be brought down, right? Particularly where utility consumption is quite significant in a manufacturing process or in a commercial building, right? Now, on the contrary, what is happening is even if you utilize the full solar photovoltaic capacity, right, we are able to generate, 15%, 20% of total electricity requirement, right? So what is happening, right? Energy efficiency is in fact crossing the impact which solar photovoltaic can do, right? Despite it's not easy to figure out energy efficiency projects because first of all, energy efficiency projects are not grossly available like the solar photovoltaic option, because solar photovoltaic option is directly proportional to your contract demand and directly proportional to the roof area that you have, right? And the free solar lights that is falling on your roof, right? However, energy efficiency has to be figured out, has to be compared with all the available options, and then. So it's certainly a difficult option, but it is surely a more potent option, what it looks like from these numbers. So let's proceed further. What happens to the ROI? On the ROI side, it's very clear that the 4 to 5 years of a payback period is there for solar photovoltaic, but whereas energy efficiency projects have a payback period of 1.5 to 2 years. So what happens is there are lots of RESCOs which are investing in solar photovoltaic, right? And they are having contracts with the users, and then they are supplying electricity at a much cheaper rate than the utility. Fine, it's one of the easiest way to get a cheaper electricity and also reduce your GHG emission, right? But this has a very, very limited impact. That's what these numbers speak, right? And if we compare energy efficiency with solar photovoltaic in further detail, so what happens is energy efficiency investment works for 24 hours, right? Because it is not limited to the availability of sunlight, right? And practically, if we see, though the sun and not availability of sun is 12 hours, but actually solar photovoltaic generation based, if we see, so actual most of the generation is in, more than 90% of the generation is in for 8 hours only, right? Then energy efficiency, the good part or as well as the bad part is that it can be applied to almost every energy consuming equipment. So the opportunity is huge, right? But that's why it is confusing and that's why it is difficult as well, right? But another good part now is that with solar photovoltaic investments, the way banks are funding solar photovoltaic investment, the banks have also started funding energy efficiency investment as well, right? So friends, with this presentation, I'm not trying to undermine the impact what renewable energy has produced or what it can produce, right? But to emphasize on the returns which energy efficiency investment can deliver. So on the investment side, it has a double of the returns. So ROI of energy efficiency investments are double, right? And the impact which it can create, right, is also maybe much larger for some of the units, right, as compared to what the impact can be created by solar photovoltaic. So only this part I want to emphasize when I am comparing, right? And I would also like to say that both the routes, whether renewable energy or energy efficiency, are not substitution for each other, right? They are not complementary to each other, but in fact they are supplementary to each other. Whatever way we are doing first, the other can follow, right? So let's proceed further. What are the problems with energy efficiency, right? Because that is the reality. That is why the adaptation has been much slower, right? Solar photovoltaic came to this world much later, but implemented much faster. The wind energy also came much later to energy efficiency, but got implemented much faster. So the reasons are, the first of the point is that how much is the saving? Who knows, right? And what happens if we don't get the returns on the energy efficiency investment, right? With solar photovoltaic option, everybody knows that there is a definite outcome, right? Maybe the overall generation may be 70, 80 or 90% or 95% of the total claimed one, but there is no doubt on the number. It can't be lesser than that, right? Which is fine. Then with the energy efficiency, the problem is that where are the opportunities? What are the opportunities? Which needs to be preferred first, right? Which one is having a faster ROI, right? What are the life of energy efficient technologies, right? Definitely, the vendors and suppliers for normal energy consuming equipments are much higher than energy efficient equipment vendors. Their availability is also far off, right? Who will maintain and operate these energy efficient technologies, right? Because most of the plant, these kind of things have not been used. Many technologies, when we recommend, we see this kind of recommend as well, that it has failed in this plant or that has failed. I don't say that things have not failed, but so has other equipment also, right? So that doesn't mean that energy efficiency should be looked upon as a not worthy option, right? So, but energy efficiency would also require shutdown, right? But whereas solar photovoltaic can be implemented absolutely independent of the production, right? So there are plus points and there are minus points as well, right? But how do we go next? Once, even if the solar photovoltaic, which is having the half of the ROI, even if that has been done first, then what next, right? So friends, here I would say that there is absolutely no way other than energy efficiency to reach out more closer to net zero dream, right? That's why the net zero dream worldwide has been kept as 2050, but we can't wait, right? We have to act on, right? There are lots of corporates who have come up with a target of 2030. India has also said that by 2030, it will have so much of its energy generation from renewable. Corporates have said that they will reduce down their specific energy consumption, right, by so much percentage, right, till 2030. So 2030 has become a immediate target, right, towards journey towards net zero by most of the leading corporates across the world, right? So here, what is happening is the energy efficiency can play an equal and probably much stronger role because of its faster ROI to renewables. That's what I would like to say here. Friends, let's proceed further, right? Let's see some of the things with energy efficiency. It is always defined as useful power out by total power in, right? The simplest of the definition, right? And on the left hand side, you can see a picture wherein the energy efficiency is getting labeled traditionally, right? On the right hand side, if you all recollect the Maruti car advertisement, wherein a long, large ship comes up, and then the person explains with so much on the technology or the features available of the ship, and the buyer talks and says only one thing, that is kitna deti hai. When he says kitna deti hai, he is addressing to the energy efficiency part only, right? And we all are concerned with our automobile, right? That how much of mileage we are getting, whether it is two-wheeler or a four-wheeler. Friends, let's see the UN sustainability total charter of 17 points. So out of 17 points, actually 5 points, right, on sustainability talks in some or the other way on energy, right? The first one is the 7th point, which talks about affordable and clean energy, right? The 9th part is industry innovation and infrastructure. The 11th charter is sustainable cities and communities. 12th is responsible consumption and production, right? It is clearly talking about energy efficiency, right? And the climate action, right? So for worldwide development in the 17 charters, on the 17 charters, total 5 of the charters are around sustainability. And in that, to achieve the sustainability, we have just seen what is the role of energy efficiency. On the left-hand side, there is a publication from Bureau of Energy Efficiency in March 2021, that what is the result which has been achieved in different sectors, that is, and through its different schemes, right? So what I want to say here is that the energy efficiency has the potential to deliver results, and it has already delivered results. On the right hand side, right, what I'm trying to say is that the number of application and number of technologies which are available are huge. There are so many, right, which is a plus point as well as a minus point. Plus point in the sense that the options are many, and the minus point in the sense that which one should I go for, right? So that's where energy efficiency stands today. Let's see some of the practical cases or actual use cases of energy efficiency. These are delivered by our company, so I thought worth sharing here, right? Wherein the contract with the customer was for 31 months. The total investment was 1 crore 42 lakhs. It was funded by State Bank of India with 12.25% interest rate, and targeted monthly saving was in rupees form, because there was diesel saving also, and there was electricity saving also. So both of the savings, when you are trying to equate in a simplest understandable format, so it is basically rupees. So it is 8,68,000, whereas the achieved monthly saving was much higher, which was 11,53,000. And these are the actual results which are achieved and delivered, right, in a bank funded project, right? And the reduction in the GHG emission was 1860 tons of CO2 per year, right, which was much bigger than any of the targeted consumption numbers for a particular facility. And the till date savings delivered for 31 months we monitored, right? So this was around 3 crores 57 lakhs, right? So financially, energy efficiency was quite a potent and quite a successful option to reduce the energy consumption and to reduce the GHG emission. This is what I wanted to say. The kind of project they were covered here was energy efficiency improvement in air conditioning. Again, there are plenty of options in that: air handling units, the laundry, the boiler, the hot water generator, exhaust system. In fact, here the boiler was totally shut off. Right, the requirement of steam was directly converted to other sources of energy, and in some of the cases, it was generated localized, and the hot water was completely generated through heat pump. Let's see the another case. Here on the left hand side, on the top side things, these are the older motors. And on the bottom side, you can see the energy efficient motors. These are basically I5 motors, permanent magnet motors, which are having phenomenally better performance, right? And the savings are also equally great, right? Like this 15 kilowatt motor has resulted into 12% savings, 7.5 kilowatt into 18, and 1.5 kilowatt into 30. As you go towards the lower rating of the motors, the specific cost of the motor goes up, but the percentage saving goes up. So practically speaking, the payback period which is getting achieved by replacement of I5 motors across the different sizes of motor is practically the same. On the right hand side also, the pictures are very small. The upper row belongs to the motor, older motors. The bottom row belongs to the newer energy efficient motors. And here is a transparent method for measuring energy consumption before the project implementation. So these 5 days consumption represent the energy consumption before the project was implemented. Then when the project was implemented, the energy consumption came down, that is the line B, and then it sustained to this. So this reflects to quite a lot of 40% saving since it was on pump, right? So when this PMSM motors are installed, I5 for the I5 motors, which is necessary because these are high frequency motors. Some of them are 75 hertz, some of 100 hertz, some of 150, some of even 200 hertz motor. So here these PMSM motors require VFD, right, which enables PMSM motor operation, and then because of the drive, we can always control the flow, whereas the earlier flow control methods were bypass or by throttling. So you get some additional savings other than the energy efficient motors. So what I'm trying to say, I'm not trying to talk about this particular technology or that particular technology. What I'm trying to say is that many cases, the investments like solar photovoltaic is done, and these kind of investments are not done, right? Let's see another case. Here on the left hand side, you see a blower, right? And in this particular case, this was even an I3 motor, right? And that was replaced by axial blower, right? Wherein you can see the shape, which is quite aerodynamic, right? So the flow of air is in one single direction, not like a circulating flow in a centrifugal blower and then moving up, right? So this is one particular case. Another particular case is the motor is replaced by a I5 motor, and motor is directly installed on the shaft, blower shaft. And along with this, because the drive was there was opportunity to match the requirement versus supply side, and the saving potential again, I mean saving what it has delivered is again phenomenal. And what is absolutely necessary in any energy efficiency project is to put up a meter, right, which makes your baseline consumption very transparently before, and then whatever may be the project, right, the supply of that project must be from the same feeder, right, so that on the same meter it measures the energy consumption, and then on the right hand side you get the actual situation. So because energy efficiency can't be seen, unfortunately, right? Or what happens in solar photovoltaic is that we know that how much of electricity is generated from a solar photovoltaic project. We know pretty well, right? But in case of energy efficiency, it's a difference of 2 numbers. The difference of 2 numbers has to be created very, very transparently, right? Then and only then belief on energy efficiency comes. Otherwise, saying that this is the energy efficiency project, right, and then saying that so much of percentage saving is there, right, without proof that it is completely transparently measured, what happens is the belief doesn't come up, because with this one single project, your overall energy consumption in the bill you can't demonstrate, right, or even in the section also you can't demonstrate, which is from your regular meter, right? These are all one-off projects. So one-off project, one has to create a facility to do the measurements, right? So, friends, again, I mean, the purpose of again demonstrating these kind of actual results which have been achieved is to just to say and share that what energy efficiency can do in our endeavor to achieve sustainability, right? So, friends, it is very clear that sustainability cannot be achieved by renewables alone, right? I think we all would agree on that. And sustainability and energy efficiency go hand in hand. We have seen that just now. Then, and that's why I say with a lot of confidence that the sustainability and energy efficiency are analogous to each other, right? And I hope you would also agree. Thank you. I welcome all the questions on the chat, please. Questions, please, if any. Is the chat box on which the questions are raised is visible to me?
Yes, you can even raise your hand and ask a question by unmuting your mic.
Please feel free. Yeah, hi Pradhu. Please, great to see you here. You are in fact one of my gurus. Yes, Pradhu, please. Mr. Padu Padmanabhan, please. No, we can't hear him.
Yeah, I think now he should be able to talk.
Hear me?
Yeah, we can hear you. Yes, please.
Milind, to begin with, I must congratulate you in linking energy efficiency with sustainability. You have really done a great job by quantifying the energy efficiency metrics with qualitative sustainability parameters. It's not an easy task, which is the most challenging task for economists around the world, but I thought you did a good job in doing that. Another way, and it's more of a comment, but really to get your comment on my comment. See, another way of looking at the connection between efficiency and sustainability is to look at the evolution of energy efficiency in India since the early 60s or mid 60s. You see, at that time, Milind, the word energy efficiency was not known. It was the concept of fuel efficiency. And it was driven by the fact that we had to reduce our petroleum oil imports, the oil crisis of 73, and so on and so forth. And all the government's action with industry, with the transport sector, was on fuel efficiency. And that was the name of the game. The mantra in the 70s was, how do you reduce furnace oil consumption, etc.
Yes.
And that moved in probably the late 70s, early 80s to looking at it a little more broadly and looking at it in the context of what are the practices, what are the methods, what are the attitudes to reduce energy efficiency. And that was done through the term energy conservation.
Yes.
In the 80s, late 80s, the word energy efficiency became part of the lingua franca, part of the lexicon. And energy efficiency was seen as a very technical subject. We read energy audits and all of that. And you're very familiar with all of this, Milind. The whole issue of how the energy audit function developed in the country. And now energy efficiency is now a corporate strategy by most companies. But that was not the end of the journey. Following that was energy productivity. where you ask the question, how is energy used, is not the question, what is it used for? What was the value addition that you could have in a particular industry so that you can earn more revenue with the least amount of energy? That was the energy productivity concept. Now is the interesting point. Now we are moving to the next level of sustainability, net zero. And what is the impact that energy efficiency could have in advancing sustainability objectives? In fact, as you very rightly said, most sustainability objectives has as part of it very fiber energy efficiency. Energy efficiency is interlinked so much with sustainability that you can't separate one with the other. The reason I mentioned this evolution is that I think that this last stage, the stage we are in, the energy sustainability, net zero, energy efficiency link that you drew up, requires further discussion and debate because our understanding of it is limited. And I'm glad that you had this conference, this webinar, because it's a good start in making this link much more pronounced, that sustainability without energy efficiency is not going to take us far. I'm sorry, I went a long way.
No issues.
Way,
you are one of the you are one of the oldest professional in this line, right?
I just thought I should let you know that you have started. You have kind of I won't say muddied the waters, but you have stirred the pot in getting a discussion going in this area. And congratulations to you once again.
Thanks a lot. Everyone, before I switch to the next query, I must like to share that Mr. Padu Padmanabhan has written a book called as Energy Efficiency as First Fuel, right? Please do read that if you have an interest in the subject. You'll get lots of insights, right? I mean, at that point, somebody who was pioneer in saying that energy efficiency is a first fuel, right? When we say fuel means I'm going to buy a fuel and then going to consume it. But then he said that energy efficiency as a first fuel, right? So very phenomenal thinking, right? Let me go to the next questions. So next question is, any suggestions on how the carbon finance can be availed for energy efficiency projects? I do not know. The person who is asking is basically a ESCO company or an end consumer of energy. So I'm going to answer for both of them. There are many banks, the public sector banks, particularly I would say SIDBI, right? They have a clear-cut financing schemes for implementing project for MSMEs, right? But like this, other public sector banks are also having schemes, right, for financing energy efficiency projects, right? And that's what can be typically called as carbon finance. Every bank which is financing a solar photovoltaic project is into carbon finance. It can be considered as. So my contact details are given. So if you have a very specific question, you can write one-on-one to me, right? If there is any help possible in availing this kind of finance, I'll be happy to connect you with them. The second question is, the i5 motor is not readily available in the market and the delivery time is longer. In this case, how can we schedule the motor replacement? This is a very, very good question by Amit Khause. See, what happens is from the regular motor manufacturers, right, like the ABBs or other multinational companies, anything. I'm not saying anything to any particular company. What I'm trying to say that these motors from them have not yet started coming, but these PMSM motors, right, are very much indigenously available. We are implementing these projects since last more than 2 years, right, and getting very good response and very good result, right? So and then some of the other regular manufacturers, they have also started manufacturing i5 motors and they are available, right? So if you're going for i5 motors kind of a replacement program, right, so instead of buying it directly from the trader, I would suggest that engage on any ESCO, right, because there are lots of other technicalities involved in the success of i5 project, right, and they would be able to make this happen for you, right? So that would be my answer. So these motors are extremely available. Otherwise, how would have we implemented it, right? In so many cases, right? That there are plenty of cases wherein this kind of project we have already done. Yeah. Any other question? Anybody has raised hand? I would request Padu to please share the link for the benefit of the audience, right, for your book. And I would very strongly recommend everyone to read that book. Yeah. Any other question or any other hand raised?
No. There are no further questions or hand raise.
Okay. Okay. So then it's from my side. Yeah, everything is over from my side. Thank you. Thank you very much.
Yeah.